So today I wanted to talk about what Apple has done with their AI push to put things privacy first, because I think it's one of the most interesting aspects of their Apple Intelligence branded set of LLM generative AI features. I made a video about the privacy a couple days ago that was inspired by that, why I find privacy important, why Apple finds privacy important. And today is a kind of more of a chalk talk down to the nitty gritty of what Apple has actually done with Apple Intelligence in order to make it, I would argue, the most private intelligence system of the level that they have made, that anyone has made, that's out there. And if I'm wrong about that, please bring things to me. I'm always happy to correct my beliefs about things. So let's start a few years ago in 2021, when Tim Cook was much more on a push to kind of like market the importance of AI. And I don't mean that for Apple, I mean that across the tech industry. He was giving speeches at privacy conferences. He was kind of like advocating much more for privacy legislation and things like that. I think Apple was praising the GDPR at the time. And one of the things that they did is they released this paper called A Day in the Life of Your Data. And throughout it here, they kind of use a little story to illustrate what goes on with the apps that are on your phone and how they collect your data over time. Now, some ways down, actually on the first page here, they have Steve Jobs' quote from the All Things D conference in 2010, one of the most famous comments that he has made when it comes to privacy, which is this: I believe people are smart, and some people want to share more data than other people do. Ask them every time. Make them tell you to stop asking them if they get tired of your asking of them. Let them know precisely what you're doing with their data, which is, I think, notable, right? Because so much of Apple's design philosophy is about taking away friction. And this is a very important place where Jobs thought that friction should be added, which is that your data, your personal data, one of the most important parts of your experience of using a computing device, should be something that that adds friction when you're about to give your private data away to someone else. Of course, there are many things since then. Apple's track record is imperfect. They acknowledge that readily. But their vision and their commitment to it and the amount of resources that they put into privacy, I think, is reflective, including this paper. So further down, they go through the story here. They kind of give some examples. I don't feel the need to go through this because I think that this is the most interesting part. Here, they talk about their 4 kind of pillars of design, or principles, I guess is what they describe them as, for increasing user privacy. The first one up here is data minimization, which means that when they do collect data, that they only collect the minimum amount of data needed in order to perform a service, basically. By the way, this is also just a good computer science principle that you should really only collect and pass along the minimum amount of data needed most of the time in order to get the result that you want. And so it just is interesting to see this in the context of a privacy document, right, which also has the same kind of set of beliefs. The second one, on-device processing. This one is one of the most unique ones, I think, because it is one that Apple uniquely prioritizes, actually to a fault at some times. Siri is a great example of this, right? People have talked about how privacy has kind of limited Siri over time. I think that with Apple Intelligence, we'll see if that has actually been correct. And a big thing that people have talked about is that because Apple prioritizes on-device processing rather than cloud processing as local as possible, it prevents Apple from collecting quote-unquote necessary data in order to make something happen. I think Apple would disagree with that. I would disagree with that, but that is sort of that was in the zeitgeist for a little while there, I think in like the mid to late 2010s. Last one, user transparency and control. That's the one that Jobs talked about, right? Making sure that users know what data is shared and how it's used and that they can exercise control over it, right? Ask them over and over again, ask them every time, ask them until they're tired of it, right? Users deserve to know when data is being shared, what data is being shared, and how it's going to be used. They deserve agency over their data. And then finally, security, which is a cornerstone and actually probably one of the most foundational technical components of maintaining a private system on a computer, which we'll discuss in a second. So I've broken these down, I've taken them out here, and I also, next to this, kind of in our Chalk Talk, have the Apple Intelligence architecture diagram that was provided. And I wanted to quickly go over this and then see how those two intersect with one another, so that way you can kind of see how Apple has applied those principles, which they talked about 3 years ago and probably have been using for much longer before that, to something that they just announced in the last month. Okay, let's go and get started. So the first thing is I'll give you an overview of what's going on in this diagram, right? So here is the diagram for Apple Intelligence. Up here is kind of the apps and experiences category. This is the thing that you, the user, see. When you open up your phone, you're using Siri, you're using the writing tools, you're using Image Playground, you're using sometimes like Spotlight, I would imagine would be included in that. You're using applications. These are the things that face the user, right? This is, of course, important because it sits on top of everything else. This is the thing, kind of the last step between the computer and the user. Now, I do have a small quibble with this, and I'm not going to correct it yet, but I'll come back to it in a second, which I think will help us illustrate what's going on in this diagram. But just know that's the user-facing stuff right up there at the top. Okay, here, what they call their personal intelligence system. This part is the stuff that's on your device, that's part of iOS, that's going to be baked into the operating system level, right? It includes, I would say, 3 major components and then one important piece of glue to tie everything together, but especially 3 major components, right? The first one is the generative stuff that they have built in, the LLMs, the actual AI, right? They actually talk about this as 2 separate models, one of which was a language model and one of which was an image model, right? And those models have this special set of parameters that sit on top of it that let it specialize itself on the fly. It would be like learning a new skill every time that you want to do something. And you don't need to know much about that for this video, but just know that that's what that part of the diagram represents. The next one is what they call the App Intents Toolbox. This is something that they've been building out for a very long time. It's something that developers actually have been building into for a very long time. It's something that's powered Siri for a while now. It's something that's powered search for a while now. If you ever use any of the kind of Siri suggestion widgets on your home screen, or if you ever see a suggestion on your lock screen or when you pull down to go to Spotlight, anytime you see like a Siri suggestion, that is most of the time part of the App Intents Toolbox. It also powers things like widgets and other kind of like little elements that break the app out of the app, if that makes sense. So going back, you can see that it has this little connection between the apps, that apps and experiences category and that App Intents Toolbox. The difference between those two things is that these apps are kind of it's like a toolbox. You go in there, it's funny that I use that word toolbox, but it is like a toolbox. You go in, you use, let's say, weather, right? Or you go in and you use something like notes, right? And that is a whole experience in itself. The app is the major paradigm. Once you're in the app takes over the entire screen. It controls what you see. The designer and the developer have worked together to lay it out, so that way there's a clear information hierarchy for you to use the graphical user interface to interact with the piece. Now, when Apple introduced widgets, one of the ways that we saw this happen is that you could break little bits of those functions out. So for example, instead of being able to scroll through the entire 10-day forecast of your weather, maybe you break out just the current weather, right? Or instead of seeing all your notes and being able to edit your notes and everything like that, you see a collection of your notes or the most recent note that you've edited. That is what this App Intents Toolbox is. Those intents, you can imagine them as, and this is a simplification, but you can imagine them as breaking out pieces of functionality from the app. It makes it so that the apps are not the primary paradigm. It's worth pausing here for a second because there's been some commentary about this, which is that, oh, Apple Intelligence signifies the end of the app era and things like that. I think there's some truth to that, but it's important to note that this thing is actually not that new. It's invested on a lot this year. They've built a lot on top of their previous design for the App Intents Toolbox, but it's something that's been around for many years to this point. In fact, some developers know that it is been changed a bunch, and that's actually been a frustration at how much has been changed. But those changes and the current approach seems to be the approach that Apple is now going to stick with. Okay, the last piece of the on-device stuff is this semantic index, which I'm going to make a video about at some point because I think it's actually maybe the most interesting part of this, one of the most interesting parts of this. But the point of the semantic index is that in the past, you have stored your data on a phone in a way that the computer can mostly understand. That is in files and folders, right? In directories is the way, like if you go all the way back to like the Smalltalk, Xerox Alto type days, and even into the era of OS 10 and Next Step, they were directory based. They were these kind of abstract trees that you had to visualize and memorize these paths through to get from one place to another. Files and folders when it came to the Mac, right? There was a graphical representation of those things. That was the computer's small affordance to the human to try and say, okay, this is how I think of things. This is from the computer's perspective. This is how I think of things. Here's something that you kind of understand, so that make it a little bit easier to navigate. The semantic index does something different than that. It provides the computer a way to think of the information in the way that a user would. And so this has required a lot of processing power to get to this point where we're able to create these for each individual on the fly. But the point is that instead of storing it in these abstract ways, I mean, it is still, don't get me wrong, there's a lot of math and abstraction behind it, but like the simplification is that instead of storing it in a way that a computer understands, it is a great leap forward in storing files and indexing files in a way that a human understands. That is, that things that have similar meanings are stored together. Things that have similar meanings to you are stored together. It's worth noting, too, that this is not something that's unique to Apple. Microsoft has done this, too, when they announced their recall feature. Other places have done this, too, in more enterprise and broader scale versions of this. This is just a new technology that is going to become more and more applied over time. And it's just that Apple is finally baking it into the system because they think it's an important part of this Apple Intelligence branded platform that they're building. So there you go. Semantic Index is a way to store files. App Intents Toolbox is a way to break functions out of apps and provide them to the system, so that way the system can provide those functions to the user when it's timely and useful, and keep the user in the flow. And then finally, the on-device models, which is sort of the secret sauce of the LLM and AI stuff that we've seen over the last couple of years. Of course, at the very bottom here, you've got the Apple Silicon. That's too low level for us to discuss right now. For the most part, we'll say that there's a lot of things that are built into the silicon that preserve your privacy and security. The part that I haven't talked about over here is this server model. And we'll get to it in a second, and you'll see that it's actually very similar to what's on your phone, and actually it's a pared down version of what's on your phone. But just know for now that that is a component that we will discuss in a second. So there you go. That is sort of the architecture overview of what Apple Intelligence is doing. And so what we're going to do is we're going to go back over here and apply each of these principles to Apple Intelligence and see how it works. So I'll drag this guy over here, and we will go ahead and start with security. So it says here that security is hardware and software working together to keep data secure. And I think that that is a great way to think of how Apple thinks about security. There's a great piece by Ben Thompson at Stratechery where he talks about the importance of a closed ecosystem in order to have an ease of implementation for privacy, right, or for security in particular, right? A big component of that is the hardware itself. The hardware has to be designed so that way, even if someone has physical access to a device, that it is not necessarily easy to break into, right? So there have to be physical guarantees baked into the actual atoms of the device that make it so that there are security guarantees that can be, assured to a user or to someone at the endpoint down the line. Again, probably too detailed for us to get into. I think it's worth noting that Apple has built in what they call their secure enclave into their chips for many years at this point. So when we talk about security and privacy, they have made a huge investment in making sure that their actual chips, their silicon itself, the heart of the computer, the brain of the computer, is inherently secure on its own, outside of the software. But then, of course, they say that the hardware works with the software. I'm going to pause here and just say that without security, privacy is meaningless, right? I can have something as private a diary as I want, but if people have the ability to gain hold of it and look inside of it, then it's it's meaningless. That's why I say that security is the foundation of privacy. And I think many have said that before too. But the point is that you start with the secure hardware, and on top of that, you build your secure software, right? One way to do that is to build encryption into the software, right? Encryption is just a way to take something that you want private and place it into a locked box that you only have the key for, so that if anyone breaks in and is able to find the box, they're not able to see what's inside the box. That's it. And so that underlays all of the kind of modern privacy and security landscape, and that is a very important piece of this. And I'll just note that both that hardware and the encryption and the software go hand in hand all the way down the line through all of these things. So I start with that because it is the foundation for the rest of the things we talk about. The second thing, on-device processing. I want you to notice how much of this diagram is on device. I'm just going to zoom in again here a little bit. Literally all of this stuff, the majority of these things, these components are built on device and stay on device. They're encrypted, they stay local to you. And the reason that on-device processing is an important principle for Apple is because, number one, it fits their business interests because they've made it do so, as I've talked about in the past. But number two, and more importantly, that the closer the data is to the user, the more likely it is to be easily securable. Think about it this way. If, as soon as I pass my data off to someone, if I were to pass it to, let's say, Google, right, I suddenly have to trust Google, right? Now, you could argue that, of course I have my phone, right? And my phone, I have to trust my phone as well. But every time that you pass that data off to someone else, you're increasing the number of people that you have to trust, right? And sometimes that's fine. That's not inherently bad in a lot of ways, but it opens up the amount of ways that your data and your information can be attacked. And so that is why on-device processing is a core principle of Apple's, because again, they make personal computers, they make devices that are for the individual, but more importantly, it is also it reduces the amount of ways that you can attack data by keeping things local. So all of this stuff over here stays local as often as possible because it makes it easily securable. Okay, data minimization. This is the part that's interesting, and this is what we didn't get to before when we talked about the other piece of the diagram. The point of data minimization is that you collect only the minimum amount of data required to deliver the service that you need. So let's say, for example, that you say that you want a sandwich from me, right? And you want to keep that information private for some reason or another, right? Well, you would probably give me your sandwich order, but you wouldn't give me your social security number or the last 5 purchases that you made or what you plan to do for the day. You would just give me your sandwich order, right? That's the whole point of data minimization, is that you pass that data onto the other person, so to speak, so that way they know what to do, but you don't pass anything more, so that way they have a very small view of what's going on. This is modeled on real-world security, by the way, right? Most of the time when I go into Jimmy John's, I'm not going to ask them to take a look at my calendar for the day. I'm going to just give them the information that I need, because that's kind of inherently what we do. And if I trust them, I might share a little bit more if they ask me more. But the point is that I'm in control and that I share only what I need. Now, this was the most fascinating part, and this is kind of the point of this video, is to talk about what Apple calls private cloud compute, because one of the goals that Apple has is to extend this local on-device processing and this minimized data, these two principles, out to a broader system. Here's why. On your phone, it only has so much processing power, right? And these LLMs require a lot of processing power to operate. That's great, because Apple Silicon is very fast, and it has built in these neural engines, these things that can do LLM and AI computations very quickly. But the problem with that is that, well, most of these other companies are running a lot of their processing on servers, because you can make servers really big and have a lot of processing power, right? So that takes us to what Apple has done to build out a server. Here's the problem with building out a server. It's exactly what I talked about with Google before. As soon as you pass that data onto someone else's computer, as soon as you start trusting a computer you can't lift, well, you have to extend your trust to something broader than the thing that's on your device, which is in theory verifiable from security researchers, is verifiable by you if you had the right information. As soon as you pass that data off to another person to run on their computer, you have a much smaller set of guarantees about what's going to go on. That's the traditional way of thinking. Now, Apple is very proud of this thing that they call private cloud compute, which the goal of which is to extend the processing power of your device to someone else's server, particularly a server that Apple has certified is trustworthy, right? And that people external to Apple can certify as trustworthy. And so, because these very powerful models need higher computing power, and because Apple wants to extend the privacy guarantees that they can from the phone to the server, that leaves them in kind of a pickle. Now, the way that they ended up doing this is basically by, number one, minimizing the data that you need, and number two, by making sort of a virtual connection to a processor that you sort of plug in to your phone. It's like entirely wrong. Don't quote me on that. But that's sort of the idea, is that let's imagine that you had this like magical processor that you could plug into your phone at any time, that you could carry around with you, right? That increased your phone's power by 10x, let's just say, right? That was kind of their goal, except for in this case, they didn't want you to have to carry anything around. And they also know that networking is good enough that they can just do it through a network device instead of having you to physically plug in a device. So what they've done here is they've built a server model that mirrors this on-device model as well. On the server, what they've done is they have said, we need a bigger context window. This is a feature of LLMs that is kind of important to them. And what that allows them to do is to reason over more context for your day in order to give you better results. Now, it's kind of interesting because this is in tension with the data minimization, right? That the whole point of sending something to the server in this case is to pass on more information so that way you can get a better answer, more reasoning, more quickly. But you can provide other guarantees that allow you to trust the on-device server as well. First one of which is that it also runs Apple Silicon. So all of the kind of security guarantees that you get with Apple Silicon, you now get on the server as well. The second thing is that it passes things over in an encrypted way. So any person in the middle who's watching you pass over that locked box from your phone to their servers can't see what's inside the box because the server has the key, your phone has the key, and no one on the outside has the key. And the last one, the most important one, is that it doesn't store data. Now, when we talk about data minimization, that's another component of it, right? One way of thinking is that you want to keep a lot of user data, right? Because then you can make predictions about what they want and you can kind of do things with that. But Apple's philosophy, because they put privacy first, is to put all of that important context on the phone, keep it on the phone, and then only pass over the important information when that computation is needed because you need a more powerful processor. You get back the answer, and then the server entirely forgets the data altogether. And so that is sort of the beauty of private cloud compute. The idea is that it extends the privacy of your phone to a computer that you can't lift in the cloud. Now, the architecture seems to make sense to me. They say all the right words. They talk about it in a very convincing way. When you reason through it, it makes a lot of sense. Nobody has gotten a chance to look at this thing yet, the same way that very few people have gotten a chance to look at Apple Intelligence at all. And so take all of this with a little grain of salt. But the point is that even the work of architecting this system that is potentially going to be very important to the future of their computing platforms, and that allows them to increase the computing power without sacrificing the privacy that's guaranteed in their phones, is a very unique thing that Apple has built here for a consumer product in particular. Okay, that finally gets us over to the fourth one, which is the other important thing. It's more of an industry thing rather than a technical thing, which is user transparency and control. So going into the event when Apple announced this, there was reports that Apple had partnered with OpenAI, and there was talks about Apple potentially partnering with Google in order to use Gemini. Apple ended up choosing ChatGPT to launch with, right? And the thought was that Apple wasn't going to build their own models, and that they were going to use OpenAI's models and Microsoft models to power all of this Apple intelligence stuff. The big concern from a lot of kind of the tech community, the Apple community in particular, going in is that as soon as you pass that on to someone else, right, you've now passed it on to their servers, and you have to trust them with their privacy. And so everyone was kind of wondering how they would square that circle, right? Well, the answer is that they just build all the technology themselves, which is a very Apple way to do it, right? Is to build everything on your own. But they recognize that there are certain things that this kind of local processing can't do, just because there's not enough computing power. The biggest of which is this kind of quote-unquote world knowledge, or these broader, more robust LLMs, these more robust chatbots that other people are building, that Apple is not really building at all. I mean, if you look back in the keynote, if you look through the Apple Intelligence keynote, there's basically nowhere where there's an actual chatbot that's involved, right? And so what Apple has done is they've partnered with OpenAI, and they're going to let Siri pass on information to ChatGPT if it feels that it cannot solve the problem on its own, right? So like a good distinction between these two might be something like, oh, what did my mom say about dinner today? That would be a query that Siri might be able to take care of for me because it has all the relevant information on my phone. But what was George Washington's famous dinner in, I don't know, whatever? My phone would not have that information on it, but the internet would, and maybe the LLM would as well. And so at that point, the idea is that this piece of the architecture, the orchestration piece, would say, hey, I don't understand what this is. I can't pass it off to the big private cloud compute. I can't pass it off to the on-device model. So instead, I'm going to pass this off to ChatGPT. And so notice that it is the last resort in a lot of cases. And that is one way to do this data minimization, and it's one way to give the user transparency and control. Because as soon as you get to the point where you're passing off for this world knowledge, it actually asks for your confirmation that it's okay, and it passes no data off beyond that. And that is kind of an interesting case that it's sort of like how when you open up Safari on your phone, you've got Google, and Google lets you search the web, right? Apple had no interest in kind of building its own search engine for the web, but it did have an interest in building a search engine for the files on your device, right? And so what you end up having is that you have this relationship where there's a company specialized for the sort of the world knowledge, and you have a company specialized for the personal stuff. And that is the arrangement with ChatGPT that we've seen here, is that it's a piece of technology that's good for world knowledge, it's good for kind of the broader picture, but it's not something that's going to be used for any of your personal information other than the request that you've created. So that's the overview. These four pieces, security, on-device processing, data minimization, and user transparency control, are all present in the system in the places that they need to be in order to make the system as useful, but as private as possible.